Solving a trigonometric equation like this is something you need to be able to confidently do. So this video is basically only about technique. I'm not going to go into an explanation of the whys and the wherefores, but it will just allow you to follow the steps, and if you stick to those steps, it will work out. So the first thing I'm going to do is take inverse sine of both sides of this equation. Inverse sine and sine will therefore cancel. I have my interval here in terms of x. I'm now going to write the interval in terms of 3x minus 45 degrees. The smallest that x is 0 degrees, so the smallest that 3x minus 45 degrees will be is minus 45 degrees. The largest that x will be is 180 degrees, so the largest that 3x minus 45 will be is 495 degrees. We then use our calculator to find inverse sine a half. But there are many other solutions. Your calculator only gives you one. We exploit the symmetrical properties of the sine function to find an associated angle, and we subtract from 180 degrees the calculator angle to find a further solution. We can exploit the periodic properties of the sine function to find more solutions. Simply add and subtract multiples of 360 to your calculator angle and associated angle. And we'll do this until we straddle the interval that we need here. There's no point in me subtracting 360 from here because that will go well below the minus 45, but I'll add 360, that 390 is within the interval, and I can see if I added another 360, I'd go beyond the 390, 495. My associated angle, again, little point in subtracting 360 because that will take me below the minus 45. And any doubt in your mind, just go ahead and carry it out. So I'll add the 360 to this. This gives me 510, and it goes beyond my interval. So these are all solutions to inverse sine a half. And it won't cause you any trouble solving for x. Here's a trigonometric equation involving the cosine function. I'll take the inverse cos of both sides. This will simplify. Again, at this stage, I'll rewrite my interval. The smallest x takes is minus 10, so the smallest 2x plus 30 will take is 10 degrees. Greatest x takes is 180. I'll use my calculator to find inverse cos a half. I'll find the associated angle using the symmetrical properties of cosine, and in this case we subtract from 360 degrees the calculator angle. So it's different for cosine. But just as with sine, we'll find further solutions by adding and subtracting multiples of 360 to both the calculator and the associated angle, such that we straddle this interval. Again, I can see there's little point in subtracting 360 from here, and actually no point in adding 360, go beyond the interval. If I subtract 360 from here, I'll get minus 60, which is below the interval. And again, no point in me adding 360. So the only solutions I'm interested here, 60 degrees and 300 degrees. And again, you won't have any problem solving these. Here's an equation involving tan. Again, we'll start off in just the same way. I'll express my interval in terms of 3x. I'll use my calculator to find inverse tan 2 to the nearest degree for this example, 63 degrees. There's no associated angle due to symmetry with tan. We simply rely on the periodic nature of the tan function repeating every 180 degrees. So we're going to subtract and add multiples of 180 until we straddle this interval of 0 and 450 degrees. No point in me subtracting 180 because I can see that will go below the 0 degrees, but I will add 180. I'll add another 180 degrees. And again, there's no point in adding a further 180. So these are the three solutions of inverse tan 2 that lie within this interval. And we'll solve for x. Hopefully you found this video useful, and if you have, then please subscribe to the channel now.